Hello everyone. So in this ELP101 project, I will be discussing the practical use of RC step response circuit through a real life example of camera flash. So the topics covered in these presentations are theoretical explanation of step responses, calculations and derivations for better understanding, different application devices of RC circuits, and brief explanation about one of them. So, what is step response? When there is a abrupt change in the input, like a step, so the response of the voltage and currents in the circuit is called the step response. This is a common way to give a circuit a little kick to see what it does and tells a lot about the properties of the circuit. So, although step response occurs for so many different types of circuits, but we are concerned here over RC circuits. So, doing some circuit analysis, assuming that the switch is open for t less than 0 and the capacitor had some initial charge which created a voltage V naught over capacitor. Uh, while we close the switch at t is equal to 0, we will notice what happens to the current and voltage as soon as we do so. In order to find that, we make the total response as a combination of forced and natural response of the step circuit. Forced response means we set the initial conditions to 0. That means the capacitor which we treated had initial voltage V naught. We will set it to 0 and then calculate what will be the response of the circuit. And secondly, to find the natural response, we will eliminate the input voltage and more of like some discharging of RC circuit type with the initial condition on the capacitor as it is, unlike the forced response. Doing some circuit analysis, the initial state when the switch was open, the voltage across capacitor was V naught and the current was 0 as the switch was open. Finally, after a long time, at the final state, the current again becomes 0 as the voltage across capacitor becomes equal to Vs, which is the external input voltage. And during the transient state, we through some calculations we derived that the expression of Vt comes out like this: Vt is equal to Vs plus V naught minus Vs e to the power minus t by RC. So here is a quick derivation of the transient response analysis of RC circuit, uh, uh, where I have combined total response as a sum of natural and forced response. As we can see, in natural response, the Vs is treated to be 0, and in the forced response, which is at t is equal to infinity, Vf was equal to Vs. These are the graphs showing the relationship between voltage and time across capacitor, and this third graph shows the condition when V naught was equal to 0, which is this: Vt is equal to Vs into 1 minus e to the power minus t by RC. Coming to some real life applications of RC circuit, RC circuits are very commonly used in cars, windshield wipers, to the timing of traffic lights, also in camera flashes and in heart pacemakers, and in many other electronic devices. In traffic circuits, these are generally used to control the duration of timer pulse, and in cars, in the windshield, something similar mechanism occurs, that when the switch closes, the capacitor begins to charge and the potential at the other wiper begins to increase and it goes up. And in the heart pacemakers, RC circuits are used for timing purposes in the artificial pacemakers to control heart rate. These are some of the images showing the circuits of traffic light controller, windshield and windshield wipers, and the heart pacemaker. So coming to our topic, which was the camera flash effect. Uh, in camera flash effects, when the capacitor suddenly discharges as soon as we presses the shutter button, it results in a current formation and the flash comes out. So as I have mentioned, when the camera is turned on, the battery charges up the capacitor, and when the capacitor can then press the shutter button during discharging the capacitor through the flash, By pressing the shutter button, the photographer disconnects the capacitor from the voltage source. I think there is some typo in this. So the circuit for the circuit for the camera flash is mentioned here. So this capacitor is charged, and when we press the shutter button, it suddenly comes to this flash point where it is mentioned, and the flash occurs. And when the camera is off, this switch goes down to this off, where the circuits get disconnected. And here is the circuit, real life circuit of the camera. Thank you. Myself Parth Soni, from Energy Science Department, Group 18.